we're asked to find the directional derivative of this function at the point 0, 0, and in the direction of this vector u, 1, 0. The first step we need to do is define the equation basically for our directional derivative. It's going to be duf. Let's go ahead and put in at 0, 0 is going to be equal to the vector. We need the f of x at 0, 0, f y at 0, 0. That vector at and then the dot product with u is equal to 1, 0. So the first thing we need to get is our partial derivatives, fx and fy. So fx is equal to, taking the derivative, okay, we need to do this in two parts. We've got the derivative, taking the first times the derivative of the second x times the derivative of cosine is going to be negative sine x y squared, and then the derivative with respect to x, keeping y constant, then also gives us y squared. This is now plus the second times the derivative of the first is simply 1. Okay, let's simplify this. And let's go ahead and evaluate it. Since we're not asked specifically for that, we'll go ahead and say that we want to come up with this. The point 0, 0 is now going to give us, well, we plug in zeros here, that just gives us 0. So we only need to worry here about what's the cosine of 0, and that's equal to 1. Okay, let's do f of y. Okay, in this case we're keeping x constant, and we're taking then the derivative with respect to y. So x comes along for the ride, but now we have the derivative of cosine is negative sine xy squared times, okay, the derivative now of that is going to be, we bring the 2 out front, xy times 2xy. Okay, let's go ahead and evaluate that at the point. Since we need just the point here at 0, 0, simple enough. We've got enough zeros in there simply that this is going to be 0. So let's go ahead and plug this in now to find the point duf at 0, 0 is equal to, our vector now is 1, 0, and dot product with 1, 0. Okay, remember this is a dot product, so it gives us a number and not a vector. So it's simply 1 times 1 plus 0 times 0. That gives us just 1. So simple enough, we have our solution for the first part anyway. We also have the question, find the direction of the steepest descent at the point P. Okay, well, the steepest descent is simply the opposite of the steepest ascent. Our gradient would give us the direction of steepest ascent. So we've got the gradient at f0 is equal to, okay, we want the descent, so we'll go ahead and say it's negative. And then our equation for this is the vector fx at 0, 0, f, y, 0, 0. Okay, well this we've already solved for. That's the same thing as what we did up here, and it gave us the vector 1, 0. So this is simply equal to negative of the vector 1, 0. Well, we put the negative in there, and we now have our vector is negative 1, 0, 4, direction of steepest descent. And that answers the second part of that question.